Hi everyone, welcome to my YouTube channel. In this video, I am going to explain you a very important topic from mathematical method of physics, that is Hilbert space. So Hilbert space you also study in quantum mechanics. So to understand the concept of quantum mechanics, Hilbert space is also helpful. So let us deal with the Hilbert space in mathematical method of physics. So definition: Hilbert space is a linear vector space. In the previous video, I have defined linear vector space. Linear vector space is a set of elements which are vectors which obey the properties like scalar multiplication and vector addition. So please watch that video so that is helpful for you to understand Hilbert space also, because Hilbert space is a linear vector space. So which has additional properties like scalar product defined in it, and also separable, and which is complete. So Hilbert space is a linear vector space which is a scalar product defined in it, and which is separable, okay, and which is also complete. These are the properties of Hilbert space. So let us discuss inner product space. Hilbert space H has an inner product space. Inner product or scalar product both are same. So inner product space definition I am explaining here itself in the Hilbert space. So inner product space as the generalization of dot product. If you take two vectors, it product either you may denote it by scalar or vector product, but inner product space is what the dot product. If you take two vectors, its product is what? Dot product. Like A dot B, how you denote the product of two vectors, dot product or scalar product you call. So inner in vector space, it is way to multiply two vectors together. Inner product is what? It is a way to multiply two vectors together, but which is a dot product or scalar product. Whose product is what? Scalar. Phi 1, phi 2. This is how we denote the scalar product. The scalar product has the following properties. So let us discuss them. Inner product is complex conjugate. If we take the inner product of two vectors phi 1, phi 2, it is what? Complex conjugate. We can write like phi 2 comma phi 1 and its conjugate. So inner product of two vectors is equal to its complex conjugate. Second property, inner product is linear in its first argument. So if we take the inner product of phi 1 with some of the two vectors with coefficient alpha and beta, that is what inner product is linear in its first argument. It is given by alpha, inner product of phi 1 and phi 2, and beta, inner product of phi 1 and phi 3. So that is what linearity. It shows linearity. Inner product is what? Linear in its first argument. So third property, inner product of a vector phi with itself is a positive number. If we take inner product of a phi with itself, that is what? Non-negative. Or inner product of two vectors is similar vectors is non-negative, or it may be equal to 0 or greater than 0. Okay, it is always a positive number. So this you should remember. And fourth one, inner product of two vectors 0 only when any of the vector phi equal to 0. So inner product or the scalar product of two vectors is equal to 0 if and only if phi vector itself is 0. So these are the properties of inner product space. So Hilbert space also has an inner product space. If Hilbert space is inner product space, then it has to follow these four properties of inner product space or scalar product. Let us go for another property. H is separable. That means Hilbert space is separable. When it can be possible, let us define it. Let us take a matrix space. So you already studied matrices. Matrix space, uh, if you consider x comma d is said to be separable if it has considerable dense subset of x. So as you can observe here, uh, matrix space x comma d is said to be separable if it has considerable dense subset. If you what is subset here? Subset is a group of elements from its uh, group itself. Okay, subset of x only in the matrix space x comma d. Let us take one example. Set of real numbers. Set of real numbers include all numbers, natural, whole numbers. Each and every number is included in uh, real number. So then we can make the subset from this real numbers. Okay, that is what the considerable dense set. You can read that subset. Let us take q. Q we used to denote rational numbers. So then q is what? Subset of what? Rational numbers in the real number, the whole group. So q we can denote p by q, where p and q are what? Integers. So p comma q belonging to the subset where q should not be equal to 0, because if we take rational numbers we write them in ratio. Q should not be equal to 0 and which belong to the real numbers. It is a subset of what? Real number, rational numbers. So that's why that subset is what? Considerable. You should read them, you should count them. So that is considerable subset. So that's why we can make the subset from the group itself. That means which is separable. That is Hilbert space is also a separable. Next property H is complete. As the name indicates, complete, that is going to be defined completely. Let us take a space x comma d is said to be complete if every Cauchy sequence in is convergence to a point x. So we have taken a space x comma d which is complete, said to be complete if every Cauchy sequence is convergent to a point x. So Cauchy sequence, if we take that is always converging sequence is what? Cauchy sequence. And Cauchy sequence is always converges. That is for real numbers, but complex numbers only converging sequence is Cauchy sequence, but every Cauchy sequence will not be a convergent sequence. You should remember. So let us take set of real numbers. Set of real numbers are the one there is no gap between the numbers. There will be a continuous flow in the numbers. So that's why real numbers are said to be complete. If you take rational numbers, set of rational numbers, two in between two numbers there will be a some gap. Okay, any of the rational numbers if you take, that is what? Incomplete. This is how we can define the completeness. So H is also complete. If you want to define Hilbert space, you should remember all these properties. First of all, Hilbert space is what? Linear vector space, and it also involves additional properties like inner product space, which is separable, and also which is complete. I hope this video is helpful for you. Thank you for watching.